good morning, everyone. I hope everybody's having amazing time at Kotlin Dev Days. At least I am. My name is Ramandeep Kaur, and we are going to be learning today about Kotlin for data science. So how many of you have earlier worked with data science or just tried out or experimented with a couple of libraries? Okay, that's quite an encouraging number. So let's go ahead and see what are the topics that we are going to cover today. First of all, what is data science and what are the challenges in the data science world? Why to use Kotlin for data science? And some of the tools and libraries that Kotlin offers for the same. The most interesting part of today's session is the demo using Kotlin Data Science libraries for analysis and visualization. And we are going to round off the talk by talking about how can we get more involved in the data science sphere in the Kotlin world, and also what is the current state of Kotlin for the data science at this point of time. So let's start. My name is Ramandeep Kaur. I'm Kotlin and Java developer at Rabobank and aspire to be a unicorn developer. Data science is one of the skill sets that I want to add to my toolkit. Being a Kotlin developer, I was very curious about finding the connection between Kotlin and data science and what Kotlin can offer for the same. During my research, I found some really interesting insights that I want to share with you today. So let's start. What is data science? In very basic terms, data science is about analyzing data and trying to find some interesting insights from it. It's a combination of different skill sets, whether it's programming, maths, domain knowledge, and it has also helped organizations to drive their businesses better. For example, when you see your movie recommendations on Netflix, this is using deep learning. And indeed, we have a lot of prominent programming languages in the data science world, such as Python, R, Julia, Scala, and many more. Now let's go ahead and talk about a term which is used quite frequently in the data science world, and that is a model. Now, when I say the word model, that's what comes to the mind. Unfortunately, I'm not talking about these fashion models today. I'm talking about something which is a bit more complex. So a data science model is a combination of code and maths. It's a solution, of course, to a problem, but more mathematical in nature. Many of you must have already heard about data science models such as neural networks, clustering, and so on. I hope you have now a rough idea of what a data science model is. I think it's time to dive into why these data science models can cause challenges. And let's look into some of those challenges. First of all, plugging in these models into the enterprise applications might be very challenging. And data science models are often written in languages like Python and R. And these languages are dynamically typed languages. Since they are dynamically typed, it's difficult to maintain your code, evolve, test, and also scale up your application in the long run. Although the data science models are often tested against test data or part of data from the production environment, they might behave very differently once they're promoted to the production environment. And now we need a programming language, which is, of course, easy to learn, has scientific libraries for computation, but at the same time is easy to maintain, easy to scale up, and evolve over a period of time. And that is the reason I'm coming to the topic Kotlin for data science. Now, Kotlin, of course, is easy to learn, read, and Kotlin is also statically typed. It means you need to define the types at the compile time. It is an initial investment to define your types. However, in the long run, it makes your code more robust and more maintainable. And of course, immutability is a big advantage when it comes to data wrangling. Being a JVM language, we can always leverage from Java ecosystem of scientific libraries, which is, again, a big plus. We can say that Kotlin is able to close this gap between data science and data engineering world, as well as software engineering world. Having described all the qualities of Kotlin for data science, I believe it's important to discuss about some of the prominent existing programming languages such as Python and Scala. And let's see how Kotlin compares with Python and Scala. Speaking about Python, Python is dynamically typed language. Again, very powerful platform, has large ecosystem of libraries for scientific computing. At the same time, being dynamically typed causes problem in maintaining your code and also scaling up your application. And Kotlin, on the other hand, is statically typed language. As we discussed, it's immutable. We can always use Java libraries for scientific computing. And using Kotlin DSL, we can also create streamlined languages for your domain-specific logic. It means that somebody who is not very technical in your team can also interface or interact with a data science model. Now let's go ahead and talk about how Kotlin differs from Scala. Now Scala and Kotlin have a very unique relationship because a lot of people view Kotlin as a better version of Scala because Kotlin has taken a lot of features and also simplified them. However, Scala has gained a lot of traction recently in the data science world because of its big data science tools such as Apache Spark. The advantage that I feel Kotlin has over Scala is, again, it has a better interop with Java than Scala. This was a bit of comparison with Kotlin, with the more prominent programming languages. However, today's focus is on Kotlin for data science. And let's discuss some of the tools and libraries that Kotlin offers for the same. Speaking about the tools, we have Jupyter Lab, or we can also use Jupyter Notebook. So Jupyter Notebook is an interactive shell wherein you can write your Kotlin code. And now you also have a Kotlin kernel for it. A kernel is a computational engine which basically execute your code inside the Kotlin notebook. We also have a web-based solution called Apache Zeppelin. This has more customizations on the top and also its own built-in plotting engine. And now Kotlin is also available for Apache Spark. And for today's demo, we are going to use Kotlin kernel for Jupyter Notebook. Before we go to demo, let's talk about some of the libraries that are quite useful in the data science world. Speaking about analytics and data wrangling, these are some of the libraries I found really useful: Krangle, Kotlin Statistics, and KMath. For visualization, Let's Plot and Kravis. If you have used R before, you're going to find it very similar to ggplot. And when we talk about machine learning, Kotlin has its own deep learning library, Kotlin DL, and it's also its own scientific computing environment called COMA. As previously discussed, Kotlin can, of course, leverage from Java ecosystem of libraries such as NDLearning4j, Core NLP, Smile, and many more. Now is the time to see some of these libraries in action. And for this setup, these are the minimal requirements. You need to have Java 8. I've already installed Jupyter Notebook on my machine, and also Kotlin Jupyter kernel for the same. Let's go ahead. You have the right view. So Jupyter Notebook is already running on my machine, and it's already running on the local host. I'm going to select a new notebook, a Kotlin notebook. Now, for the data science workflow, we have different steps that we need to follow. For example, loading the data, data pre-processing, data cleaning, analysis, and visualization. However, in the interest of time today, we are going to focus on data analysis, data pre-processing, as well as visualization. Now, in order to use any library in Kotlin, we need to use the use keyword and the name of the library. And the library that we are using today for data pre-processing is Krangle. And for the demo of today, we have a very happy data set. In order to load that data set in the Jupyter Notebook, we are going to use data frame from Krangle. And we have a read CSV method. Since the format of the file is in CSV, I already have this file in the root folder. Now, if we have a look at the data set, we have a list of countries based on region, and they are ranked according to their happiness score. There are certain factors that affect the happiness score of the country, such as GDP, family, health, trust, generosity, and so on. Let's go into some of the data pre-processing steps and see how can we check some of the rows, columns, filtering, sorting, these kind of basic data pre-processing steps. First, let's save the data frame in a variable called happiness. And let's see how can we see the schema of the data frame. Calling the schema function, we can see the list of columns, the type of columns, and also their values. Now, in order to retrieve the first 5 values from the data frame, we can call happiness.head function. Similarly, to retrieve the last 5 values from the data frame, we have happiness.tail. Now, let's go ahead and see how can we select rows and column. In order to select the rows, we can call rows.elementAt. Let's say we want to select the first row from the data frame, so it fetches the rows for country Switzerland. Now, we can also select multiple rows by slicing the data frame. So there is a function called slice, and slice function takes in variable arguments. So we can specify from 1, let's say 1 to 5. Now, one thing to note here is in slice function, index starts from 1. The reason being slice is derived from R, and in R, index starts from 1. Although in Kotlin, for arrays, index always starts from 0. So this is one thing that we need to keep in mind while using slice function. Now, let's go ahead and select some of the columns. So for selecting a specific column, we can select, let's say, country. But I have a better function, which is a select function, because you can give in variable arguments at the same time. We call the select function. We can specify country and also, let's say, region. So now we have selection of multiple columns at the same time. Now let's also perform some basic sorting and filtering on the data frame. In order to perform sorting, there's a function called sort by. And let's say we want to sort by GDP. By default, the sorting is in ascending order. We can also perform the sorting in descending order by calling sorting by descending order. So now you have the result set, which is sorted by descending order based on GDP. Now let's go ahead and talk about some filtering and how can you group data together. So for filtering, we can call filter, and we can specify the criteria on which we want to filter our data frame. Let's say we want to filter the rows for which GDP is greater than equal to, let's say, 1.2. Now we have a short form, GE, and if we specify GE 1.2, it will give us a result set for all those values that satisfy this criteria. We can also perform a count on it. And now we have count of those rows. Similar to the shortcut GE, we also have less than equal to LE and EQ. Of course, we can make the criteria more complex by adding an AND operator and providing more criteria for filtering. You can also negate the criteria by calling a not function on it. So if we call a not, we have a count for the criteria that fulfills this specific value. Now, this was basic about filtering. Now, next thing is how do you group data? For grouping, we have a group by function. And let's say we want to group by region. Now, when I see the result set, I actually don't see the groups, although it says it's grouped by region, but where are the groups? So in order to see the groups, we call the groups function. And now we can see it has grouped the data based on different regions, Western Europe, North America, and so on. We can also perform count on this and check how many data points exist for each of the group. If we remove the groups, yes. So if you see here, you can see that for Western Europe, 21 data points exist, and similarly for other regions. Now, important step in data pre-processing is summary statistics. Now, how can we perform summary statistics on the data? First of all, for a specific column, we can simply calculate a mean, median, standard deviation, maximum or minimum value. So let's say we want to calculate the mean value for GDP column, and we call the mean function. Now, Kotlin provides you an option to perform summary statistics only on the non-null values. So there is a flag called remove NA. If you set this flag to true, you have mean calculated only for non-null values. Now, there is another function which is quite useful for summary statistics. That is called a summarize function. So let's see how it works. Let's perform it on a group by data. So we group the data first by region, and then we call summarize function on it. Let's say we want to see data group by region, and we want to see corresponding mean of GDP for that specific group, for that specific region. So we create a key, mean of GDP, and we then select GDP from the data frame and close it in the brackets and calculate the mean, of course, on the non-null values. Now, if we see the output, it has calculated the summary statistic, that is the mean of GDP, based on group by information. So till now, we have discovered some of the quite simple functions for selecting rows and columns, whether it's sorting and filtering. Now let's move to something which is visually more appealing, and that's visualization. Let's plot some of the exciting plots that we have. For plotting today, we are going to use Let's Plot. So Let's Plot library in Kotlin is very similar to ggplot in R. And for plotting, first we need to prepare the data. So let's prepare an input data in form of a map. Let's first try to plot a bar graph first based on happiness score and region. So we create a map of happiness score, and we select happiness score from the data frame. And happiness score is in doubles, so we need to convert it to doubles and then convert it to a list. Similarly, we create a key for region and select the region from the data frame happiness. And region is in strings, so we need to convert it to strings and then list of data points. Now our data is prepped for plotting. Now let's plot. We call the Let's Plot function, feed in the data, given the input, and now we specify what kind of plot we want to plot. We want to plot a GOM bar plot. We can specify what we want on X and Y axis. For X axis, let's say we want to have region, and for Y axis, happiness score. So we now have a bar graph. Let's make it a little bit beautiful, I would say, by filling in the color based on region. And now we also increase the size of the graph by calling ggsize function. Now we have a beautiful bar graph. Another graph that I want to discuss today is called a point plot or a scatter plot if you have used Python, which is used to compare relationship between different variables. And in the interest of time, I'm going to copy the map that we have already created above and use the same for point plot. We already have two variables, happiness score and region. Let's add in some more variables. Let's say we want to also have health. And similarly, we select health from the data frame. Health is again in doubles, so we convert to doubles and then to a list. Let's also factor in a GDP for a region. And again, we select the GDP from the data frame, which is in doubles, convert it to doubles, and then to a list. Our data is prepared. Now let's plot the point plot. We call the let's plot function, we feed in the data, and then we specify what kind of plot we want to have, which is a GOM point plot. We specify what we want to have on x-axis. Let's say we want to have health. And on the y-axis, we want to have happiness score. Let's first only factor x and y and see how the plot looks like. Let's increase the size of the plot a little bit by calling ggsize function. Now, the last part of the plot looks more linear, but not quite in the front. Let's see which of these data points represent which specific region. So we can say that the color, we can specify the color based on specific region. And also the size of the data points, we can say that we can factor in GDP. So we can define the size of the data points equal to GDP. And see how the graph now looks like. So with this graph, we can see correlation between different variables, and we can see the front part here, which is quite non-linear, belongs to sub-Saharan Africa. And if you hover on each of the data points, you can also see the GDP of that specific region. Now, in the interest of time, I've already plotted 2 additional graphs that I want to show you to you guys today. And we also have a correlation plot, which is quite useful in the data science world for finding the correlation between different columns. And for correlation plot, we call the core plot function. And again, we need to convert it to data frame into a map. And we can also select a color palette if you want. Another plot that I find very useful is a box plot. A box plot is a plot wherein you can check the outliers of the data. The outliers are the points which are either extremely high or extremely low. So it's quite similar to what we did earlier. We created a map, and herein we have used GOM box plot. And you can identify how many outliers exist in your data that are on extreme ends. Talking about the data science workflow, we have other steps like data cleaning and modeling. So I already prepared doing some data cleaning by replacing the values, null values with the mean values. Also for data modeling, I have used Smile Kotlin library and performed rig regression and tried to predict the happiness score against the actual happiness score of the data set. However, honestly, this needs another session to dive in to see how we can do data modeling with Kotlin and then see the results of the models.